Hey guys, so today we're going to be in chapter 2, section 3, which is all about linear functions and slope. If you look at the word linear, you notice that it starts with the word line, and that's what it means. A linear function is a line. So we're going to learn about the slope of lines today and how to find them and use them to graph and all this kind of stuff. So the slope is really the change in your y's, which is your vertical, over the change in your x's, which is your horizontal. A lot of times we'll hear that referred to as rise over run. If you're given 2 points on a line, then you can look at their y values and take the difference of those, and look at the x values and take the difference of those, and that's going to give you the slope. So that's what the y2 minus y1 over x2 minus x1 says. So you have two different y values because you have two different points. So you have your first point, which is y or x1 y1, and you have your second point, which is x2 y2. And that's going to give you those different values. Obviously, we have to put this little thing in there where it says that x2 minus x1 cannot equal 0, because if it does equal 0, then it's an undefined slope because we never want 0 in our denominator. And we also usually refer to slope by the letter M. Sounds weird. You think, oh, it's slope. You should say S, but we don't. We use M. So here's a picture that kind of helps show this y2 minus y1 over x2 minus x1. Here's our line, and we have our first point right here, and we have our second point over here. This first point lies at x1, y1, and our second point lies at x2, y2. And so our rise is our y2 minus y1, and our run is our x2 minus x1. So you always do your second point first. Now, does it really matter which of these points that we designate as our first point and which one we designate as our second point? It doesn't. The only thing you have to be careful about is that the x's stay with their appropriate y's. So I can't take y2 minus y1 and x1 minus x2, because then I've flip-flopped them and I've changed the entire problem. So you do have to be careful in terms of that, but otherwise you don't have to be that careful. So let's go ahead, and I am going to scroll up just a little bit, probably that much, just so that you can see the points there. But I'm going to work these problems on the board as well, so that you can see how to find the slope if you're given two different points. So I actually need to move you this way and run right into the desk. There, that's pretty good. So we're finding the slope, and we're given two different points. We're given -3, -1, and the point -2, 1. So remember, ordered pairs are given in x, y's, but since we have two of them, I'm going to label one x1, y1, and I'm going to label this other one x2, y2, just so that we don't get them confused. So slope is y2 minus y1 over x2 minus x1. So y2 was for my second point, which is 4, minus my y1. Now y1 is negative, so I don't just put a 1 there. It's minus y1. So it's a minus, all over x2, which was -2, minus my x1, which is -3. That's 4 plus 1 all over -2 plus 3. That's 5 over +1, which means we have a slope of +5. Okay, what about this other example? B, we have the points -3, 4, and the point 2, -2. We're doing the exact same process. So slope is y2 minus y1 over x2 minus x1. Notice that I'm using a formula and I'm rewriting it every time. I'm sure you're tired of hearing me say that, but the reason I do that is so that it gets in my head. I need to memorize these formulas so that I can use them whenever on a test or the final, it asks me to find slope. I'm not, oh, was that x2 minus x1, or was it x2 minus y2? Like, what was that? The more you write it down, the repetition of it's going to get it stuck in your head. So So y2 is -2 minus y1, which is 4, all over x2, which was 2, minus my x1, which is a -3. So -2 minus 4 is a -6, and then that becomes 2 plus 3 on bottom, which is a -6 over 5. So I have a slope of -6/5 for that second line. Like, this is assuming that there's a line going through these 2 points. Okay? Slow it down. Need to be for the next problem. Oh, right there. But I'm going to scroll up and talk to you a little bit on the notes first. So here's another chunk of notes. This is a good little chunk. There's actually 4 different types of slope. If you noticed, our first example we had was +5. Our second example we had was a -6/5. So there's positive slope, there's negative slope. There's also zero slope where there's no rising or just the running. And then there's undefined slope where there's always rising, but there's no running, if you're thinking about rise over run. So if you look at the first graph right there on the left, that is a positive slope. We are going from negative x's and negative y's to positive x's and positive y's. So this is a slope that is positive, it's greater than 0. Slopes that are negative, they fall as you go from left to right. So we read from left to right. So a positive slope goes up as you read from left to right. A negative slope goes down as you read from left to right. And this is when slope is less than 0. The zero slope, notice that it's just flat. It's a horizontal line. There's no rising or running, or there is running, there's no rising. So these look like y equals some number, like y equals 3 or y equals -4. That's what they are. Notice there's no x in them because x doesn't matter. No matter what x is, y stays exactly the same. And so these are y equals equations, like with no x's. The flip of that is the undefined slope. That's where it's completely vertical. There's a whole bunch of rising and there's no running at all. So if you have rise over run and there's no running, that means you have a 0 in your denominator. And that's undefined slope. These are x equals equations. So like this would be x equals 2 or x equals a -5 or whatever. That's how you get those vertical graphs and that undefined slope. Now the main form that we want to get is the slope-intercept form. If you are asked on any problem ever to give the equation of a line and it does not tell you a specific form that it wants it in the slope-intercept form. So if it doesn't say, point slope form, if it just says, give me the equation of a line, that's the form you need to work down to, okay? So keep simplifying it and working through it till we get to this slope-intercept form. The slope-intercept form is y equals mx plus b. Remember, the m is our slope. That's what we find by doing rise over run. That b that's tacked on there at the end is our y-intercept, and that's an ordered pair of 0, b. Your y-intercept is where your graph crosses the y-axis. And so that's really important to have. With those 2 bits of information, you can graph any line at all. If you know the slope and the y-intercept, because that's all you need to graph a line, is you need to have one point and the slope. That's why slope-intercept form is so nice for us to use. So when we are graphing with the slope-intercept form, what you're going to do is first you're going to plot that y-intercept, that 0, b. Then you're going to use the slope to rise and run in order to find a second point. Once you have 2 points, you have a line and you're good to go. So I'm actually going to leave this up there right now while we do our first example so that you can see how this process works. The example on the board says graph f of x equals a -3/2 x plus 2. And so it wants us to graph this We don't have any other information. The way that we would have graphed it before is we would have done our table with our x's, and then we would have computed out our y's, which is fine, but it takes a lot of time. When it's in y equals mx plus b form, it makes it really nice. Y equals mx plus b. So without doing any type of math, just by looking at the equation, I know that I have a slope, an m of -3 over 2, because it's right there in the equation. I also know that my b is +2. The b is the y-intercept, and as an ordered pair, that's the point 0, 2. With this information, I can plot this line. Okay, so 0, 2, I'm going to graph that first because that was step 1. So I go up 2, and then I use my slope to plot another point. Well, how do I do that? By remembering that slope is rise over run. So if this is rise, this is telling me how far up or down I'm going to go, and it's a -3. That tells me I'm going to go down 3. And then my run is a +2. I'm going to run to the right 2 spots. And here's why. On our coordinate system, positives are up, negatives are down with our rising. With our running, negatives are to the left and positives are to the right. And so with that information, I can graph. So I'm going to start here at my y-intercept, and it says I got to go down 3. So I'm going to go 1, 2, 3, and I go to the right 2, 1, 2, and I plot that second point. From there, I can connect my dots, and I have my line. Whenever you graph any line at all, you always can double check, at least in a general form terms of by looking at your slope and saying, okay, I had a negative slope. Do I have a negative line? Does it fall as I go from left to right? Yes, it does. And my slope was negative. So at least there I know that I didn't accidentally drop a negative or move up when I was supposed to move down. So that's how you graph using your slope and your intercept. So now let's look a little bit closer at horizontal and vertical lines. I'm not going to write these on the board simply because there's not really much to do with them. Horizontal lines, they have a slope of 0. Like I said, those are y equals a number. So the general form is y equals b. That b is just any number. Notice it's b, just like up here, this is our y-intercept, was also b. That's why it's there, because your y-intercept here is going to be at b. So these look like this. Our example is y equals 3. Well, when x is 0, y is 3. When x is 3, y is 3. When x is -452, y is 3. So these are horizontal lines like that, and the slope is 0. And then vertical lines are x equals a. Notice there's no y-intercept, and that's because these run parallel to our y-axis, and so we're not going to have any y-intercepts. We do have an x-intercept though, and so then that happens at a, whatever that value is. For this example, x equals 2. So when y is 0, x is 2. When y is 6, x is 2. When y is a negative 103, x is 2. So these are vertical lines, just like this. And when you have a vertical line, you don't have any running, so your bottom of your denominator is 0, and so that is an undefined slope. So those are just two kind of more specific examples of that. All right, and we did slope-intercept form, y equals mx plus b, and I told you that's always your end goal whenever you're writing a line. But there's also the general form. That's where you have ax plus by plus c equals 0, where a, b, and c are real numbers, and a and b cannot equal 0, because then it doesn't have one of those variables. So that's your general form. And if you are given the general form, then you want to get to the y equals mx plus b form, because then you're able to graph from that form, just like we did here. Okay. So let me slide you down so you can see the general form. There. And I scrolled down just a little bit here so you can see it here as well. But we're going to find the slope and the intercept for 3x plus 2y minus 4 equals 0. So just looking at that, I can't say, okay, well, my slope is 3. No, we don't know that. Just because it's in front of the x, it's not in slope-intercept form right now, so I can't deduce that. So my goal is to get to this y equals mx plus b form. So how do I do that? Well, the first thing is, if you look at this equation, notice y is by itself. So that's what I'm going to do. I'm going to focus on getting y by itself. I'm going to move everything else over and leave the y by itself. So I'm going to subtract over the 3x. And I'm going to add over that 4. So that I'm left with 2y equals a negative 3x plus 4. Now, y still isn't by itself because it has that 2 in front. So I'm going to divide everything by 2. And notice I did every individual term by 2 and not just the whole shebang with the 2. And that's because I want it to look like y equals mx plus b. 2 divided by 2 is 1, so it goes away. So y equals a negative 3 halves x plus 2. Now I have it in y equals mx plus b. So if I need the slope, that's my m. My slope is the negative 3 halves. And if I need my b, or my y-intercept, that's the number on the end, which is 2. So my order here for my y-intercept would be 0, 2. This is the exact equation that we just had a minute ago that we graphed from. And so you could be asked to graph this as well, but we're not going to do that because we've already done this graph. But that's how you would do it. You work the problem by isolating your y, so you get it into y equals mx plus b form. Then you would still do the same steps. You would plot your b, and then you'd use your m, your slope, in order to plot another point. Okay, so what if they tell you something really specific, like using the intercepts to graph a line? I know for a fact on some of your homework problems, it specifies use the intercepts. And I know that on a test, it could specify use the intercepts. And if you don't use the intercepts, you will get it wrong. So pay attention to what your instructions say, okay? So if you're using your intercepts, what that means is you're using the 2 specific points where your line crosses your x-axis, that's your x-intercept, and your y-axis, your y-intercept. So how do we find that? I mean, from here, we know our y-intercept, but we haven't said a single thing about our x-intercept yet, have we? And no, we haven't. And we don't want to be graphing to try and find it. So here's what you do. You find your x-intercept by letting y equal 0, because your x-intercept is of the form x, comma, 0. And then you plot it. So you plot your x-intercept, x, comma, 0. Then you find your y-intercept by letting x equal 0. And then you plot that x, or that y-intercept of 0, y. And then you're going to connect those 2 intercepts because you have 2 points, and once you have 2 points, you have your line. So let's do an example, because this is a little bit different than the other ones that we've been doing. And the example is right there on your screen on my notes page, but I'm going to write it up here as well. 4x minus 3y minus 6 equals 0. Notice we don't have to rewrite this. We don't have to get y by itself or anything else. We're just going to find the x-intercept and the y-intercept. So to find the x-intercept, we let y equal 0. So that would be 4x minus 3 times 0 minus 6 equals 0. 4x minus 6 equals 0. 4x equals 6. Divide both sides by 4. X equals 6/4, which reduces down to x equals 3/2. So that means that my x-intercept is 3/2, 0. So I'm going to go ahead and graph that. 3/2 is 1.5. So I'm going to put that right there on my graph. Now, to find the y-intercept, you could manipulate the problem around to where you had it in y equals mx plus b form, but that's usually going to be more math than if you just simply let the x equal 0. So that's 4 times 0 minus 3y minus 6 equals 0. Negative 3y minus 6 equals 0. Add that 6 over, divide by negative 3 on both sides, and you get y is negative 2. So that means my y-intercept is the point 0, negative 2. So I'm going to graph that on my graph as well. And now that I have both, I can connect them. So I used my two intercepts to graph this line. Again, if it asks you for the intercepts, you must give those 2 points on your graph or it will be incorrect. So be careful with that. Okay. So here are some other equations of lines, and some of these we've already talked about. I'll stand out of the way and just talk off screen so you can still see the problem. But these are all different equations of lines. There's the point slope form. That's one we haven't talked about yet. That's y minus y1 equals m times x minus x1. So you use the point slope form when you have the slope and at least one point that lies on that line. The point is the x1, y1. We're going to do a problem with that in just a second. The slope intercept form, I told you that's always your goal to get to. That's the y equals mx plus b. You have your horizontal slope or line equation, which is y equals b. You have your vertical line equation, which is x equals a. And your general form, which is ax plus by plus c equals 0. So let's do some examples using that point slope form. Point slope form is the y minus y1 equals m times x minus x1. We're going to do two different examples. And I will have to angle you a little bit for the second example, and that's okay. But example number 1, it says to find the equation of a line with the slope of 2 through the point 3, 5, which is right there on your screen. So this one gives me the point and it gives me the slope. And I know that my point slope form is y minus y1 equals m times x minus x. So I'm going to substitute in the values that I know. My point is x1, y1. So y minus 5 equals m, which is my slope. My slope is 2, times x minus x1, which is 3. Now, don't just leave it like that. That's not the equation of a line. Because remember, if it says find the equation of a line and it doesn't specify the form, you want to get to that slope intercept form, that y equals mx plus b form. So I'm going to distribute my 2 into the parentheses. So it's 2x minus 6. And then I'm going to add the 5 over in order to isolate my y. Negative 6 plus 5 will give me a negative 1. Now I have it in y equals mx plus b form. So there is the equation of a line through the point 3, 5 with the slope of 2. Okay, so what about this example? And I will scroll so you can see it on your paper. What if it says to find the equation of a line through 2 points, 4, negative 3, and negative 2, 6? So it said that I was going to use point slope form, but it doesn't give me the slope. It only gives me 2 points. So what do I do? Well, what do you need to find slope with? You need 2 points. Do we have 2 points? We do have 2 points. So the first thing you're going to do is you're going to find your slope. Okay, so find your slope. Slope is y2 minus y1 over x2 minus x1. So y2 would be 6 minus my y1, which is a -3, all over x2, which is -2, minus my x1, which is 4. That's 6 plus 3 all over a -6. It's 9 over -6. Both of those have a 3 in common, so I'm going to simplify that. So that's a -3 over 2. So there's my slope. My slope is -3/2. So now I have the slope and I have 2 points, but I only need 1 point. So you just pick one. You can either do 4 -3 or 2 -6. It does not matter which one you pick. Mathematically, at the end, you will get the same conclusion as long as you've done your math correctly. So I'm going to choose equation number, point number 2. I'm going to use this one, and my y minus y1 equals m times x minus x1. So y minus y1 equals m times x minus x1. Since it's already a minus, I'm just going to switch it to a positive to save me a little bit of board space. A minus becomes a positive. So now I would distribute my -3/2 into this parenthesis. Y minus 6 equals a -3/2 x. And then the 2 and the 2 would simplify out to where I just have a -3 there. I'm going to add the 6 over to get y by itself. So y equals a -3/2 x plus 3. That is the equation of a line through the 2 points for -3 and -6 or -2, 6. So if you're given 2 points, you have to do a little bit more math because you have to figure out what that slope is first. Okay. So there's my work. Maybe there it is. But I'm going to do an extra example just because I know this one has some extra steps to it. So it's going to be exactly like this one. Extra example. And the lighting makes it kind of hard to see that. But it's right there on your paper as well. We're going to find the equation of a line through the point -3, -1, and 4, -1. Okay. So the first thing I have to do is I have to find my slope. y2 minus y1 over x2 minus x1. So y2 is -1 minus y1, which is -1, all over x2, which is 4, minus x1. That gives me a -1 plus 1 all over 4 plus 3, which gives me 0 over 7, which is 0. Maybe you need to remember this or have a refresher, but let's see, where should I put this so that it's on the screen? I guess over here. 0 over a number is 0. A number over 0 is undefined. Okay, because you don't want 0 on bottom. If you get 0 on bottom, that's a trouble thing, and so we call that undefined. 0 on top is okay, and that gives you 0. So we have a slope of 0. That's not a big deal. You treat it the same way. It actually makes our life a lot easier. We're going to do point slope. It doesn't matter which point you pick. I'm going to pick point number 1. So y minus y1 equals m, which was 0, times x minus x1. This is why it's actually kind of nice that we get a 0 for our slope, because 0 times all of this means it goes away. So we have y plus 1 equals 0, so y equals a -1. Notice that there is no x. There's nothing else over there. There's no slope listed, there's no x, and that's because our slope was 0. And when our slope is 0, that's when we have our horizontal line. And that's a good thing because that's what we got as our equation. We have y equals -1, and that's the form for our horizontal lines. So that's okay. You can still mathematically do the work even when you get the slope of 0. And that is the end of 2.3.